Welcome to Math Study Tutorials, and in this video we're going to be looking at the concept of electric charges, potential and field. But in this video we are starting off with electric charges, and then for successive videos to be uploaded, right, you get videos on potential and the field as well. Okay, so starting with electric charges, it's important to note that one, it's a fundamental property of matter that causes subatomic particles to attract or repel each other. So it's a property, right, that a body can acquire that makes it attractive. That's why it leads us to the fact that we'll say, okay, like charges repel, unlike charges attract. So when a body possesses a charge, there is now a tendency for it to be attracted to another body. Do you understand? Then the second point here is that it comes in two types. A charge can either be positive or it can be negative, and this was coined by Benjamin Franklin. You see this in the text for the course. So the third point is a body made attractive by rubbing it against another is said to be electrified. So there's a situation whereby you have two different objects, and then by the time you rub them together, there is now transfer of electrons. So when there is now transfer of electrons, one will be positively charged, another will be negatively charged, and that leads to what we call electrification. That's why it says it's said to be electrified. Next point, the rubbing allows the transfer of electrons between two neutral materials, and it's important you know what a neutral material is, right? First of all, from chemistry, you know that we have different, for an atom, which is the smallest part of an element or a particle, right? So this is the atom, if this is the nucleus, right? And then you know that this is the nucleus, and inside the nucleus, what do we have in the nucleus? We have the protons and the neutrons, right? And then outside, what's happening outside? Electrons are revolving around that nucleus, right? So it's important to know this first of all. So what does it mean for it to be neutral? So on a normal basis, just an atom on its own that has not undergone any form of charge, the number of protons is always equal to the number of electrons. So it's now when there is a change, and also it's important to know that these protons are confined in the nucleus, so their number doesn't change, right? The number doesn't change, it remains the same. So on a normal basis, number of protons is equal to number of electrons is neutral. So by the time these particles are rubbed together, right, there's now a transfer of electron. So maybe if this one had 5 electrons, it may now give out some electrons to the other, right? So it now becomes maybe 4 electrons. So you can now see that at that point the number of electrons in the one that transferred will not be equal to the number of protons that are confined in the nucleus, right, causing one to be positively charged. And from the script, you could see that having lost what electrons, and the other to be negatively charged, having gained electrons. So we can therefore say that when an atom does what loses electrons is positively charged, and when the other gains, it becomes negatively charged. So this leads us to the fact that the study of charge systems that are at rest or that are stationary is known as electrostatics. You'll be asked this in the OBJ part of the exam, right? Study of charge or charge systems that are at rest. You could use the word to understand it. Electrostatics, something that is at rest. It's not something that is dynamic or changing. Do you understand? It's at rest. So these charges are associated with insulators, conductors, and semiconductors, which we'll look at later in this series, right? So before we continue, please do well to subscribe to this channel if you've not, so that you get other videos that relate to this course and other science courses to help you understand concepts in depth and pass your exams. Okay, next point here is that the electric charge is a fundamental quantity. Remember, from physics 101, right, we have the fundamental quantities and the derived quantities. The fundamental quantities are what? They are independent of other quantities. They are just on theirs, but the derived depend on other fundamental quantities to be defined. If you look at the first point, we mentioned that it's a fundamental property that causes, right, a body acquires a charge, right? So there is no other factor, it's just a property that a body exhibits. Just like you say, the mass of this guy is 5 kg, right? Mass is actually what? It's a fundamental quantity. There is no factor that is affecting it. Do you understand my point? So another point here is that the SI unit of electric charge is a coulomb. It could be asked in the exam. The SI unit of electric charge is what? Right? It's important to know that this SI unit is the coulomb. And then if you then want to write it out, you have 5C negative tensity. That's if the charge is negative. Remember we said there are two types of charges. You have the positive and the negative charge, and then it is represented by Q. That's the small letter q or the capital letter Q in most equations, like you'd see in Coulomb's law, right? Q1 Q2 over the 4 pi epsilon O and then r squared, right? Okay, so Coulomb's law explains with respect to magnitude the force of attraction. So we are talking about these charges now. We said that when electrification can take place, right, and then the body is made attractive or is made to repel another body, right, when it acquires a charge, right? So if we now want to consider what are the forces that exist, right? Remember we said like charges would repel, unlike charges attract. So what is the force that exists between these two that have these charges? That's studied with the Coulomb's law, right? As well as the force exerted by charge on another, right? If maybe you're looking at a test charge, another. Then lastly, I said this before, unlike charges attract while like charges repel. So if you have positive, what's going to happen? There's going to be a repulsion. If it's negative, there's also going to be a repulsion. Then if it's a positive, negative, what's going to be? It's going to be an attraction because they are unlike charges, right? So it's also important to understand the acquisition of charges after rubbing, right, which is also known as charging by friction. It's important to know that there are three methods of charging an object. We have the charging by friction, we have the charging by conduction, or it's called charging by contact, and then we have charging by induction, right? So let's start off with the charging by friction, and this is associated with rubbing. That's why I said charges after rubbing. So when you rub the two particles against themselves, there's a frictional force that, you understand, and then this leads to acquisition of charge. So let's get right into it. So first of all, I've said this before, the atom is made up of the nucleus and the electrons which revolve around it. I'm sure you understand this, right? And then these electrons are negatively charged, right? Very important. The electrons are what? Negatively charged, while the nucleus is made up of the protons and the neutrons. The protons are what? They are positively charged, while the neutrons are what? They don't have any charge. Even from the name you'd see that they are neutrons. They have no charge, neither positive or negative. You get that? So for a stable or neutral atom, remember we said before that for a stable or neutral atom, the number of electrons is equal to the number of protons. This can be asked in the exam. When an atom is neutral, what happens? Number of electrons is equal to what? Number of protons. Not number of protons equals number of neutrons, right? The number of electrons is equal to the number of protons, right? Then when there is instability, if maybe the species involved now loses electron, you can now see that there will now be inequality in the number. So let's say A had 5 electrons, right? Watch carefully, and B had 6 electrons. I'm just giving a case study. So if B gives out 2 electrons, so if B has 6 electrons, that means that B has 6 protons, because B is now in a normal state, right? And A is also in a normal state. So it has 5 electrons and has 5 protons. So this has 6 electrons, has 6 protons. So if it gives out 2 of its electrons, right, to A, and then if it gives it to A, what happens here? That means this becomes 7, right? So it has given 2 to A, then 5 plus 2 is what? 7. So since it has given 2 over to this has now become what? 4. Do you get that? I remember that the proton number does not change because it's confined in the nucleus. It has 5 protons, it has 6 protons. The proton number doesn't change. So you can now see that number of electrons is now greater than the number of protons in A, and then the number of electrons in B is less than the number of protons in B, right? So when there is more protons, what happens? It's positively charged, right? It's positively charged. Then when there is more electron, it's what? Negatively charged. So let's move on. As I said, the protons are locked up in the nucleus, so their number remains constant during rubbing, right? So when rubbing is ongoing, the material with higher electron affinity will accept electron from the one with lesser electron affinity. You study chemistry, know that electron affinity is actually an energy required for an atom to do what accept electron, 1 mole of a gaseous atom and stuff like that. But basically, we are now talking of the ability. If you check the meaning of the word affinity, what's the tendency for it to do what accept electron, which is still connected to the energy required to do what accept that electron. Do you get that? So when the two materials come together and they are being rubbed, the one that has the higher tendency to accept electron will not accept electron from the one that has lesser electron affinity. And when one accepts electron, what happens? You see that when the gains is what negative, and then if the ones that now lost electrons will be positive, right? So we move over. The material that lost electrons to the acceptor will have a lesser number of electrons than protons. Hence, the effective charge on the material is positive as proton number exceeds electron number. Do you understand? So the proton number is now dominant. So this method of charging is associated with the triboelectric effect. This is another important point to note, right? As part of what was mentioned by the lecturer in the notes he personally gave, right? The triboelectric effect. And what's this all about? It's a simple thing, right? The triboelectric effect is all about bodies that acquire charges due to contact. Remember, we mentioned 3 types of charging, right? We talked about the charging by friction, charging by contact or conduction, and then charging by induction. So when two bodies come together, right, by contact, or they come together via rubbing, that's the frictional stuff. So the fact that they are now able to acquire charges via that means of rubbing or coming in contact with each other is known as the triboelectric effect. And now this leads us to another important point, and then that's talking about rubbing, friction, charging method, right? So you could be asked in the exam, okay, this material and this material, which will be positive, which will be negative when they are rubbed with each other, right? When they are rubbed with each other. So starting with amber and wool, right? Wool is going to be positive, and why is that? Wool has lesser electron affinity than amber. So the wool electrons in wool will now be transferred to amber, and then since amber has accepted electrons to be what? Negatively charged. And then the hard rubber rod, which is also known as the ebonite rod, and 4, when they rub together, 4 has lesser electron affinity while rubber has high electron affinity when compared with 4. So 4 will do what? Give out electrons. When 4 has given out electrons, it will be what? Positive, while the ebonite will be negative. Then the glass rod and the silk. The glass rod and the silk is going to be negative because it has higher electron affinity. So when a glass rod and silk material is rubbed together, what happens? Electrons are transferred from the glass to the silk because what? The silk has greater electron affinity, higher tendency to accept, and when a species accept electrons, it becomes what? Negatively charged. Then polythene and dry wool. You can see that dry wool has a very low electron affinity. So the same thing that happened with amber and wool, where wool was positive in amber and wool, and then is also positive for polythene and dry wool, right? So dry wool will be positive, polythene will be negative because polythene has great affinity for electrons. Then the cellulose acetate and cotton. What happens here? The cotton has higher electron affinity than cellulose acetate. So the cotton will accept electron from the cellulose acetate, and then this will be positive, this will be negative. And all this revolves around the concept of the triboelectric series, right? The triboelectric series. So you won't say, how do we know if this is positive or this is negative? It's something that is practical. That's why we have what's called the triboelectric series. Watch carefully at the screen. Have the positives and the negatives. So these different materials have been studied, right? And they have now been, the electron affinities have now been compared. So they've now carried out various experiments, and then this series was brought up. So it's based on this series that you will now know the material that has higher electron affinity or the one that has lesser electron affinity. So the one that now has higher will accept electron. So it's just important you know the basic ones. These ones I put up in the table are the basic ones which are likely to be asked. Glass, you can see glass is on the topmost section, right? right? It has very low electron affinity. You can see it's on the positive side. You can see where wool is, right? You can see 4 over there. You can see silk, right? You can see silk over here. Remember, you said when glass was rubbed with silk. So since glass is more positive, that means it has lesser electron affinity than what? Silk. Because if a material is positive, that means it has tendency to do what? Give out electrons. Are you following? So silk that has higher electron affinity will do what? Will accept electrons from the one that's upper here that is positive, which has higher tendency to do what? To give out electrons. Do you understand? Okay, so let's move on. So glass rod and silk. Silk has more electron affinity than a glass rod, so it accepts its electron and becomes negatively charged. The glass rod, having lost electrons, becomes positively charged. So it's important you get to know all these common materials, because you could be asked, just like in secondary school, these questions like this were seen, right? One of the most common ones is ebonite rod and 4. I'm very sure of that. Ebonite rod and 4. When ebonite rod is rubbed with 4, which one is positive, which one is negative? So all these common ones mentioned in the table, do well to master them, understand them, watch videos to help you visualize and to practicalize all that is here. Okay, so it's also important to note that during charging, the magnitude of the positive charge attained is equal to the magnitude of the negative charge attained by the species that accepted. Remember, when you accept, it's going to be negative, right? So if, for example, 2 electrons were lost, remember we say when you lose, a species loses electron, it becomes positively charged. So if 2 electrons were lost, what's the charge attained on it? +2. And then 2 electrons will now be accepted from the one that was lost. So one of the species will lose, another will do what? Accept it. And that one that accepted it, when it accepts, it becomes negatively charged. So it becomes what? -2. So it can then be deduced or inferred that in an isolated or closed system, that's where no external force or external system is acting, the net charge that will be produced on a material, right, or during the process of charging by rubbing, is 0. You can see it here. So the one that has lost electrons will be what? +2, while the one that gained will be what? -2. When you add it together, the net charge is 0. So we move on to the fact that we say that these charges cannot be created or destroyed, but are transferred when rubbing takes place, and the total net electric charge within an isolated or closed system remains constant. This is known as the law of conservation of charge. You can relate this to the law of conservation of energy, right? But in this case, we're talking about the total charge remaining constant, even though maybe we can have it from one form. There's now transfer of what? Electron, but at the end of the day, everything remains constant. Do you understand? Everything remains constant, provided that it is what? An isolated or a closed system. So from this, we can then deduce and we can then say that another property of a charge Q is that it is conserved, right? Refer to that. We mentioned other properties. We mentioned the SI unit, right? And other stuff that are associated with charges. They can be positive, negative. Unlike charges do what? Attract, while like charges repel. Those are the other properties we mentioned. And then another property of charges is that charges in different bodies are quantized. So when you say charge in different bodies are quantized, what does it mean? That means it occurs in integral or discrete amounts, right? So let's say we have a large hole now. We have a large hole, and then we're now looking at the minimum, the discrete amount that are now making up this entire hole. Do you understand? So it occurs in integral or discrete amount with plus E proton or negative E electron. Because remember, proton is positive, electron is negative, as the smallest possible unit of charge. So starting from the smallest unit E, it can now build up to 50 E, 10, 100 E, 1000 E. You can just keep building, but that is the minimum, and that's the discrete amount for which it was built. So that's the quantization there. The next point, very important, is that the charge Q is equal to plus or negative E. the charge Q on a body is equal to plus or negative E or negative Ne, where N is the total number of electrons, because remember each electron will have what, right? Each electron will have what? That's a charge, right? Which is the E, which we said is the smallest possible unit of charge, right? And you know the guys that discovered the charge on an electron, 1.6 times 10 raised to power negative 19, that should be R.A. Millikan, right? R.A. Millikan. And then he discovered that what happens here, the protons and the electrons, they have the same magnitude of charge, but the only thing is that the proton is positive while electron is negative. So when you are now calculating for N, it can either be the total number of electrons or the total number of protons. So this plus or negative Ne implies that if you are looking at protons, what you use is positive Ne. But if what you are now looking at is electrons, what will you use? Negative Ne. Remember I was talking about discrete amounts. So each atom that is here now has electron on it. So you first of all determine the number of atoms that are present in the given mass of material, and then you get the N and then multiply by E, because each of those will possess what? E, a charge of E, which is 1.6 times 10 raised to power negative 19. Are you following? So N is equal to the product of the number of atoms. You first of all determine the number of atoms in the given mass. We'll take a question now, and then the number of electrons in each atom. So let's say there are 5 electrons in each atom. So you first of all get the number of atoms that are present and then multiply by the number of electrons in each of the atoms so that you can get the total number of electrons. And then since each of those electrons have E as, that's the smallest unit, as that's the charge on each electron will be 1.6 times 10 raised to power negative 19 coulombs, you now multiply so that you find the effective charge, because each of them have that 1.6 times 10 to the negative 19C. Are you following? So let's move on. So it's also important to note that to determine the number of atoms in a given mass of the material, first of all, you must know that 1 mole of a substance, from chemistry, 1 mole of a substance contains 6.02 times 10 to the 23 atoms, right? So to determine, you first of all have to get the number of moles, because this is just a standard, right? We have 1 mole will give us 6.02 times 10 to the 23 atoms. So you now say, okay, given the mass, that based on what is given to you, you first of all have to get the number of moles. And how do you get number of moles? The mass of the material divided by what? The molar mass of the material. So when you now determine the number of moles, it will now be, let's call it X moles, will now be equal to what? The number of atoms. Let's use a question mark. So if we then cross multiply, that implies that the total number of atoms is equal to what? X, the number of moles, multiplied by 6.02 times 10 to the 23rd atoms. So once you get the number of moles, multiply by Avogadro's number. So let's take this question. It says, what is the total positive charge of all the protons in a 1.2 gram sample of carbon, given that the atomic number of carbon is 6 and its atomic mass is 12 grams per mole? Take Avogadro's number to be equal to 6.02 times 10 to the 23rd and E to be 1.6 times 10 to the negative 19 coulombs. So from charge quantization, I mentioned it, we have that Q is equal to plus or negative Ne. But since we are looking at protons, remember protons are positively charged, which formula will be used? We are going to be using Q equal to plus Ne, or we can just write it as Ne. Are you following? So how do we calculate N? Do you remember? You first of all multiply the number of atoms by what? The atomic number. So why are we multiplying it by the atomic number? Do you remember what the atomic number means? Do you remember what the atomic number means? What's the atomic number? It's equal to what? The number of protons. It's also known as the proton number. And we're looking at the total positive charge of all the protons. So you have to determine the total number of protons that are there, right, in each atom. Do you get that? And then multiply by the number of atoms that are present in the 1.2 gram sample. so that we can get the total. Are you following? So you will now have to get the number of moles of carbon. You can see the question, it was given that is a 1.2 gram sample. So that's the mass divided by the molar mass, or we call it the atomic mass. That's 1.2 divided by 12. We'll give you that's the mass divided by the molar mass, which is 12. That gives you what? 0.1. So you now multiply the number of moles by what? 6.02 times 10 to the 23rd to determine the number of atoms. After determining the number of atoms, each of these atoms have 6 protons, because it has been given to you that the atomic number of carbon is 6. That implies that in each atom of carbon, it has 6 what? Protons. So you multiply by 6 to get the total number of protons, which when calculated, you will be having 3.61 times 10 to the 23rd protons, to 23, right? Protons. And you've gotten that, which is your n. So that is the n, and then multiply by what? E, because each of these protons have what? Plus E. If it was electrons you were asked for, you multiply by minus E. So when you now multiply 3.61 times 10 to the 23rd by the constant, which is 1.6 times 10 to the negative 19, what will you be having? 5.78 times 10 to the power 4 coulombs, right? And this is the what? The charge, the total positive charge of all the protons in a 1.2 gram sample of carbon. Okay, so moving on, it's important to note we've already stated the fact that Q is quantized and is equal to plus or negative NA. And that leads me to the question I saw in the continuous assessment booklet, where they asked which of this is not true of an electric charge Q. So all these things I mentioned, you're supposed to understand the properties, know them. The charge Q is quantized, number one. It is conserved. Q is conserved. It obeys the law of conservation of what? Charges. Are you following? Obeys the law of conservation of charges. And all other properties we've mentioned, they can either be positive or negative. Unlike charges do what? Attract. Like charges repel. These are the things you could be asked. Which of this is not a property of what? Electric. So knowing all this, you should be able to answer it. So also note, so from this now, you can be asked for the value of n. You can be asked for the number of protons. So you have to make n the subject of the formula. So dividing through by plus or negative E, the number of protons or maybe electrons will be what? Q all over plus or negative E, which I have written over here. And then it's also important to note that NC, which represents nanocoulombs, is equal to what? Times 10 to the power negative 9. So let's say you have 8 nanocoulombs. What does it mean? 8 times 10 raised to the power negative 9 coulombs. So in case if is now symbolized, you would understand the meaning and calculate accurately. So if you now see this represents the microcoulombs, right? And it's times 10 to the what? Negative 6. So let's say we have 5 microcoulombs. So it's going to be 5 times 10 to the negative 6 coulombs. And then lastly, we have the picocoulombs. These are the most common ones. There are others, right? And it represents times 10 to the negative 12. Okay, so we are gradually coming to an end of this video, right? We're going to solve another question, and that will wrap this up. So recall that the unit of electric charge is coulomb, and then from the equation Q equal to IT, one of the current equations, Q equal to IT, Q is equal to the current flowing times the what? Time. So where I is the current, you can see that the coulomb is the charge flowing through, because remember that the unit of electric charge is the coulomb. So it's a charge flowing through a cross section in 1 second when a current of 1 ampere. So which implies the product of what? The current and the time. But since we are looking at a coulomb, right? 1 coulomb, we are looking at 1 amperes and then in 1 second. The current and then times the time, which in this case by default 1 second. So let's take this question and then this video comes to an end. Okay, so we have a plastic rod is rubbed against a wool shirt, thereby acquiring a charge of negative 0.8 microcoulombs. How many electrons are transferred from the wool shirt to the plastic? This is one of the questions asked in the exercise in the text. So let's solve it together. So using what I've just explained, you can actually pause the video and attempt this, where I mentioned that we have that Q is equal to plus or negative Ne, and you can make N. In this case, you are asked for the number of electrons that are transferred from the wool shed to the plastic, right? So we can see that N is equal to Q over plus or negative E. So the question now is, are we using plus E or negative E? Are we using plus E? So since we are looking at electrons, what are we going to use? Negative E. So N will be equal to Q all over negative E. Q has been given to us in the question as negative 0.8 microcoulombs, right? So negative 0.8 times 10 to the negative 6, because this is micro, I said this earlier, and then divided by negative E. Remember the value of E, 1.6 times 10 to the negative 19 coulombs. So negative 1.6 times 10 to the negative 19 coulombs. So the negative and the negative, we're going to have a positive, right? And then when we multiply this, if we divide this by this, we're going to have 1 over 2, right? 0.8 divided by 1.6 is 1 over 2. Then multiplied by, if we divide this, what is it? It's going to be 10 to the negative 6 and then negative 19 using the division law. And then half is 0.5, right? And then times 10 raised to the power. Negative is a positive, and then negative 6 plus 19 is what? Is 13. So 0.5 can be written as 5 times 10 to the negative 1 and then times 10 to the 13. Then using the multiplication rule again, what are we going to have? 5 times 10 to the negative 1 plus 13, which is same as 5 times 10 to the what? 13 negative 1, which is what? 5 times 10 to the 12 electrons will be transferred from the wool shed to the plastic. So from this, it can be deduced that if a plastic rod is rubbed against a wool material, what does this mean? And you can see electrons are transferred, which means that the wool has lesser electron affinity than what? The plastic rod that has greater electron affinity. So it will accept the electron. So electrons will be transferred from the wool to the plastic, while the wool, having lost those electrons, will be what? Positively charged. So the question is asking you how many electrons. So it's what? 5 times 10 to the 12 electrons. Thank you so much for watching this video to this point. I'm very grateful. Once again, I remind you, do well to subscribe to this channel if you haven't, that you get to know other concepts in the course as well as other science courses, right, so that I can understand concepts in depth and ace your exams. Also note that I offer private one-on-one and group sessions for science courses, right? So if you're interested, please do well to check the description of this video and book a class. Thanks once again and have a nice day.